Simon?
Yes, can you hear me?
Yes, I can. Hello, Simon. How are you?
Hello, Katie. I'm very fine. I'm excited to speak here, and thank you so much for the invitation. A few words to myself. I am the head of product management at SLM Solutions. We have, in our company, it's all about metal AM machines. And yes, I'm with SLM since 2 years now, but I have spent now in metal AM. And I'm looking forward to that great panel and discuss some very, I think, important questions, how to integrate metal AM into existing process chains.
Yeah, definitely. Oh, Michael, do you want to go ahead with your presentation, your introduction?
Finally it worked. My name is I joined Solucon earlier this year. I've been in sales positions, various sales positions in the last couple of years. But I started in a small AM service bureau. So this is where, I was operating metal machines and plastic machines and doing all the stuff that you do in a service bureau. So that gave me the hands-on experience that helps me now with the customers to ask the right questions.
Yeah.
And now the knowledge from the sales side, selling printers of all kinds, helps me now to induce that knowledge into the Solucon company and help them grow and stay on top of the food chain.
Oh, that's great. What about you, Olivia?
Yes, do you hear me?
Yes.
Good. So finally, I succeed to connect me. So I'm very happy to be there here because from my point of view, I work at CIRIS. CIRIS is a technological research centers. So we have a lot of experience in additive manufacturing. So I would say a brand new team leader for the additive manufacturing team since September. So it's very news. So I'm very excited to exchange with Michael and Simon about these very interesting topics indeed, because for our industrial also, this is a very hot topic indeed to make the choice.
Yeah, but we are going to start the conversation with Simon. As a manufacturer of metal AM technology, I know SLM Solutions provide industrial AM systems to different company profiles that encounter different challenges at the manufacturing level. Simon, do you think that those company profiles are always aware of all the considerations that should be taken into account for such an investment for an optimal integration and use of AM technologies?
There is the answers between yes and no. So there are these very educated buyers from big companies who have invested a lot or investigated a lot in metal AM already via research institutes and their corporate research labs. So they are very well educated, and I think they know what they have to consider. But there are also companies wanting to invest in metal AM, not having a big knowledge base. And I think key is for everyone to start looking for a valuable business case first, to start with the applications view, to identify suitable applications for this process, and then start from there. So yes, there is a broad variety of customers that approach us. Some are very educated, some are really new to the business, and with these kind of customers, which are pretty new, we spend a lot of time with them to explain the advantages.
But what are usually the main features to take into account when investing in a metal AM systems first?
Yeah. So there is a machine which is a cost factor for sure, but metal AM is, you have to consider the whole process chain from the data preparation to the process itself to the post processing, and then for sure also the depowdering of the parts, the yeah, all the post process that is needed to come to a final part that you can ship to a customer. So this is one part. There's a lot of invest to do along the process chain. And then I think very successful customers, they also invest in their facilities. So I think if you want to produce high value and high quality AM parts, you need to have the right facility. That means humidity control, temperature control in the facility. So these are also costs that you have to take into account when investing in metal AM.
Yeah. I know Olivier will be giving his point of view later on, because as a user, I don't know if they have encountered such type of considerations before investing into their AM systems. But I wanted Michael first to share his point of view on that topic. I believe that Michael will be sharing his point of view from the post-processing perspective.
Yeah, of course. So it's it's what Simon said. It's a lot. It's not just investing in the printer. You have to take in consideration what you need in peripheral equipment, and that's sometimes forgotten. Obviously, because the printer is a huge cost. So sometimes people think, or customers think, that's about it. But as Simon said, there is all kinds of customers in the field. Some are very educated, some are not. It's usually on trade shows, if we're gonna be able to go to trade shows again. But in the past, usually at trade shows you see the shiny parts, all perfect, no powder, no ports if possible. Then it's I call it the dark side of AM. It's where you have to get your hands dirty. You have to remove the powder, which it's vital to the process, and that's sometimes forgotten. But this is also, you have to make up your mind if you want to invest, that you see all the aspects that are needed to get the parts out and to ship it to the customer. And that's it's a lot of peripheral equipment that you need.
How is this important? How this stage is it important? Because we have so many types of peripheral equipment that can be used with an additive manufacturing system machine. I mean, what would be the reasons why, for instance, an operator should choose an automated post-processing system rather than a manual process to achieve this stage?
Well, it's I would say it depends. That's always the answer in additive manufacturing. It depends. But it's if you want to go into production or create parts that are a bigger batch number, you need to have a certain certification. If you go into like medical or aerospace, everywhere where you need a certification, then you need to make sure you have the most possible repeatability in the process. It can give you in best cases, obviously, a Solocon machine, but you need to have a machine that repeats the same step over and over again, because operators can make failures. The one operator turns the part left, the other one to the right. And you for certification, you want to have everything in the same way, so you can make sure you have no human failure in the process.
Yeah, sure. Olivia, any point of view from Siri's perspective on that topic? Or I don't know for how long Siri has been using additive manufacturing. Could you please just give us a short story about that, and how and why you've decided to invest in EM technologies, and most importantly, how do you leverage these technologies as part of your activities?
Yes, indeed. So we work in this field, I would say. Since more than 30 years ago, we start with a first SLA in polymer. So we have a lot of experience in our team about these topics. And at this time, the goal was to investigate the potential of these new technologies. So at this time, it was, I would say, taken like a new technologies. Now, this kind of machine start to be much rather than industrial systems. So, and it's a reason why we have to focus on other topics for traceability and quality insurance for that. So at this time, 30 years ago, it was more a topic of rapid prototyping. We didn't speak about additive manufacturing. Now we speak about additive manufacturing. So it's like a standard system to produce parts like machining machine, I would say like that. So yeah, we have a lot of experience about that, and indeed, I would like to continue on what I have just explained, Michael, about the point of the cleanability of the way to clean the part. Indeed, when we look to the cost, I would say overview of a part, we see that the manual action for when you need to clean the part has a big impact on the budget. So if you succeed to make it more in automated way and put more, I would say, a better reliability on this kind of process, it will also improve the final quality indeed.
Did you invest in both AM technologies and automated post-processing technologies? So
we invest indeed not automated post-processing system, but we investigate the fact to apply, I would say, scenario in order to clean part. And we see that if we follow some kind of procedure with some kind of specific I would say follow-up for that, we can reach a better quality. For example, we had case studies, for example, heat exchanger. And if we, for this kind of example, it's very difficult to remove powder inside the internal channel. And we have to, I'd say, follow to the part some kind of movement in order to allow the powder to follow the channel in order to find the exit for part removal indeed. So indeed, we see that they have an interest to make these cleaning steps in a more control way, I would say.
Okay. Well, Simon, do you want to share something about it? Or because I know, if I'm not mistaken, that SLM also has, I mean, a specific way of thinking about post-processing.
Yes, sure. So for us as a metal AM machine manufacturer, I think we cannot offer all the post-processing solutions that are out there because it's very dependent on the application. For ourselves, we have really, for us, the depowdered substrate plate. That's where we currently set our boundary. So what we are going to offer. So we also have unpacking solutions in our portfolio. We have manual unpacking stations. We have the fully automated unpacking station within our SLM hub. So we offer a broad variety, and it really depends on the parts itself, the complexity of the parts. We have internally defined different complexity grades of parts and different clean levels. And if we look with customers on the applications, we can rate the clean level requirement, we can rate the complexity level of the application, and then we can determine the right solution. And for sure, in some cases, we don't have it on hand, and then companies like Solocon can come into the game and maybe provide a even more sophisticated unpacking solution as we do. So I think that's how we define it. So we want to provide a one-stop solution, but we also have partners in our ecosystem ready for our customers if they have some additional requirements.
Yeah. So let's try to foresee how things can be improved and how the current needs of industrial actually can be met, especially with regards to this uncertain socioeconomic environment. According to you, what are the key factors that could help increase the integration of AM technologies in various industries? Are there any specific actions that should be taken to help companies become more familiar with it, be it advanced users or beginners, in the AM journey, in the additive manufacturing technology? Sorry.
Yeah. So I think key is knowledge transfer. So we invest a lot in the knowledge transfer to our customers. That means we have a lot of trainings that we offer to our customers to bring them up to speed, from basic technology trainings to basic operator training, but also to more advanced trainings. So I think this really helped the customer to be more educated. Then we also offer some consulting services already, individualized to the customer needs. So we help the customer in pre-industrializing their business case. So we look at their parts, we help designing the part in the right way to it can be manufactured on our machines without any problems and to the right costs. We define the nesting on the build platform with the customer to get the maximum out of it. We look at the post processes. We consult them regarding the post processes. So this is something we do in individual projects, always having the business case in our heads, because in the end, the only thing that counts for our customer is that they have the best possible return on investment. That's the key for us, and that's why we educate and consult customers that way.
Yeah, Michael, do you have something to share regarding this?
Yeah, I think first of all I have to agree to Simon. So it's in the end, because the customer will purchase the equipment and he expects to have the best possible solution. I think that's exactly what is needed in these times, especially because people are not throwing around with money. That has to be very conservative, especially at the moment. So it's critical to have like a very solid financial situation for the customer, so that he knows with the equipment he purchases, he will have accountability for his success. That's very important. But speaking of the network, SLM is offering a lot of options for their printers, and I would say it's mainly around the printing business, printing the part, and the designing. And it's a very broad field, and it's a very wide network of peripheral equipment that is needed, like for the post processing, which obviously we are specializing in this, and we because we knew it's very difficult for the customers to get all the information that he needs. We started to form a network with the company Asonic and with the company ULT, and we created the brand AMP Plus, which focuses on the post-processing, on the powder handling, because the powder, as we know, can be very tiny parts that are even go into your lungs and can transfer into the blood even. So we just make sure that if the customer is interested in a industrial solution, not the one machine, just the real. If somebody wants to go big on metal printing, then we have the opportunity to explain to the customer everything he needs for his powder handling. And this is why we don't want to invent the wheel again. So we are the specialists for the depowdering of the part. Then we have the company Asonic, who take care of all the powder sieving, powder conditioning, powder conveying, and ULT is taking care of all the air in your process room and make sure that everything is safe, because that's in the end we're talking about efficiency and all that stuff, but the operator can work in a safe environment is from my point of view, is the responsibility of the owner, and he has to make sure that his guys can work efficiently, but he has to make sure that they are not harmed in any way.
I think there's one question that just come up that I will read before Olivier takes the floor, and that one is from Denise, who is asking, how do you identify the parts and sorting after the 3D printing process? Because this is quite still an intensive manually process. How could this be improved?
Is it a question for Simon or for me?
I think that's a question for both of you, and then Olivier might be able to relate if he has any experience to share about that. So, but from what I can say, it is first of all, a question that relates to post-processing. How to identify the parts and sorting after the 3D printing process. This is quite still an intensive manually process. How could this be improved?
So that's to identify whether the part is good or no good?
I will just ask Denise to clarify this way as this question. I don't know if Simon has something to share about that question.
I understand the question in a way that as you have to remove the parts from the plate at one stage, normally that's after the fine depowdering, and I think to identify when you have 100 parts on the plate, when they fall down during the sawing or erudating, how you can identify that which part is which part. So I think it's a really good question. What you can do is you can print little flags with the part, which are attached to the part that you can break off afterwards. That's one option. Another option is that you can make a little mark on the parts before they go into erudating or sawing. So there are various ways, but they are all currently very manually. That's definitely correct, and I think the industry has to think about a more automated process here. And I believe it's also a good question to Olivier, maybe, because you are printing parts all the day, and you need to make sure that you have the parts in the hand that you wanted to print. So.
Yeah, that's it.
Yeah, it's true, but I would say for all sides, for research point of view, we used to indeed day per day, put I would say a tag on the part in order to find the good part. And indeed, but for maybe the question also is concerning how can we measure also the status of this part, for example, the cleanability of this part. And for point of view, we are working on a standardization project in which we assess how we can measure the cleaning aspect of the part after all the post-processing steps indeed, because this is very important topics, especially for aerospace application. If we have loose powder that will go outside after in the space, it will be problematic for optical systems, for example.
Yeah. Dennis is adding that placing a tag is also time consuming and material expensive. And that he wanted to, for Michael to answer, he clarified his question by adding that he would like a perspective from customer identification of the part and quality control. So I don't know if that helps a bit to answer that question from your point of view or not.
Yeah, I think it might be that because obviously the sooner you know the part is bad, the less time you need to spend for putting the part into some kind of cost-expensive treatment, which I assume that SLM has some software in their process chain that detects failures in the part, in the powder bed and whatever. So that would be the very first step to sort out that part. Maybe even during the printing, when you see it's becoming bad, you don't need to print it anymore, because then you're saving time and money. In the end, what our part would be that the part printed successfully, then we can make sure that the powder is out. And then we are just one step in so many steps. So, but if the part is getting put into space, you have to have a certain heat treatment or post-processing step. And for especially if you're heat treating and there's still powder inside the part, then this loose powder will stick to the walls and it will solidify, and then probably your very thin conformal cooling channels will be clogged, and the part is broken. It's not broken, but it's unusable. So yeah, this is multiple steps in the process chain where something can go bad, and the sooner the better, obviously.
Yeah, sorry, Simon, go ahead, please.
Yeah, thank you. Yeah, so I agree to what Mike said. There is in our machines we have layer control system, laser power measurement, and then MELPU monitoring. There you can already identify quite early if you're producing a good part or a bad part. So and then for sure, depending on the industry, there are various quality controls that people do after the process. It ranges from CT to penetrant testing. So various types of things is done. I also have seen some companies using CT methods to check the part cleanliness level. So to check if there's any residual powder in the channels of a part. So I've seen that as well, because it's definitely a challenge for parts with internal capacities to check if there's any powder in or not. So there are various ways.
Yeah. There is one question that has been asked by another company, and that has not been answered this morning, and which is, how do you identify the best AM printing technology to use for a given part, a component or a subsystem? I think that's a question that needs to be answered here.
Maybe can I try to give a small small answer to that? Because for me it's very case by case that we have to study that, because according to the requirement of the part, we need to identify which technology as the best one to use indeed. And there are 7 different families of technologies is an additive manufacturing process. So all these families has a set a limitation. And the first point will be to start from the requirement of the part. What we intend to do with that. Do we have access to the design in order to adapt the design, in order to adapt the part to the AM limitation? And when you have all these questions, maybe we can make a choice for the technical point of view indeed. Because we have also SLM process, laser beam melting process, but there are also EBM process, DD process, there are plenty of different process. And it's very a topic of case by case that we have to choose the best, I would say, AM process chain, I would say like that.
Yeah. Don't know if Michael Simon wants to share something about it.
Yeah, I think Simon, since he's from the printing side, I'm just doing the rest.
Okay.
So.
There's not much to add. Let's say I think we also have a lot of customer requests for parts, and then we see how far we can come with our technology. But we also are very honest to our customers if there are parts that can be printed with another AM technology cheaper or in a better way. So I'm quite open there. I think speaking for our SLM process, selective laser melting process, I think the outstanding capability of that process is really the geometric complexity that you can get out of the process, and also the material properties that come out of the SLM process. So that's why our process is used for really high challenging parts from automotive, aerospace, and turbine applications, and so on. So this, I can only speak for our technology where you should use it, but definitely for all the other technologies like binder jetting, DED, there are all applications out there where these technologies make sense.
Yeah. There's one question from Sukaina that just comes up. Is there some software that helps the user to identify that the configuration of the part is suitable or not during the preparation of B plates, for instance? I'm not sure that I understand the question. Don't know if
Well, if I might answer, I think Materials Magics has the build creator. I don't know it's a long time ago that I used it, but they have kind of an automatic process that orientates the part the way you want it. You can somehow twist it and tweak it. But I think that's one of the holy grails, the orientation of parts to make them that they don't get loose on the plate, but also to have as few support structure as you want, because you have to remove that one. But I'm not aware of a software that can do it in a proper way automatically.
Okay. All right.
I'm not aware.
Olivier, Simon, do you have a point of view on that topic, on that question?
Yeah, I have the same feeling. Indeed, there are some solutions, some blocks of solution that allow to make, for example, simulation of internal stresses for supporting stuff, because internal stresses, it will be material dependent. If we produce titanium part on SLM machine, it will be not the same story that create aluminum part on SLM process. So for internal stresses, I would say. So there are software that allow to make simulation about that, to try to assess in advance the risk to make a wrong supporting strategy. But it's also behind a lot of engineer works behind to have a good interpretation of this stuff. I know that indeed Materialize works on automated solution in my know-hows, but indeed they need also a lot of works behind to have a part ready to launch, I would say. But a lot of people work on these topics, I mean.
Yeah, absolutely agreed. And I think key is here to actually the simulation of the process. And there are some software suites out there in the market already, but let's say they are more or less standalone software packages. They are not integrated in any data preparation software like Magix. They are not integrated or connected to the machine. So both options I see in the future to do it, and then we hopefully come to the point to have a more automated part preparation and less human efforts there, because I believe it can be done, but simulation is key here.
Okay. Just looking why moving forward, I mean, right now, do you think that in the long run, people are still going to buy machines, or are we going to enter a new era of business where we will have more services than actually commercializations of machines? Because I know that right now on the market we have some 3D printer manufacturers that actually do not sell their machines, but they used to provide services to help, customers from all industry to actually leverage the technology without having them, because that's another way to invest in the technology. I don't know if from the depowering point of view, I don't know if in the long run we are going to have, for instance, Silicon providing, only depowering services to the industry, and SLM Solutions does the same thing, with their 3D printer.
Simon, you want to go ahead, or I can answer? I think I think it's an old discussion with having a printer or having the service, and it's always, I think it's heavily dependent on whether you it's going to be R&D parts that you need for your production. So you want to make sure the IP is in-house and it doesn't go anywhere. But if you have rather simple parts that are not really a huge IP behind, then yeah, why would you have all the capital invest in your company if you can just order it from some service bureau? So I think that's going to be a little bit of a wave, because sometimes, well, probably at the moment it's more buying the service than the capital equipment. But I think it also depends on what application, and I agree with Simon that the SLM process is for highly intricate geometries like aerospace, medical, where you don't print routing parts. That's too, the geometry is too difficult, and that's why I think the SLM process is a standalone quality in this area. But if you have simpler geometries, I think I forgot my thread. Well, it's going to be dependent on, you want to have high IP, you keep it in-house, and if you can have rather simple parts, you will probably give them to a service provider. That's my opinion, my personal opinion.
Yeah, thank you. So for you, we just need to keep, the IP in-house, the intellectual property in-house. Okay. Simon, what do you think?
I hope we will still buy machines like we do at the moment. So I'm not seeing a big change of business model in the next couple of years, but for sure we have discussed internally as well if we need to find other models than just selling a machine. It's an interesting question, but I compare it always with the machine tools, CNC machine tools, milling tools, and so on. And I think there we see that machines are still sold. There are service bureaus offering services. Machines are leased. There's leasing options. There are also, I think, in some cases, you as a customer, you buy a certain output, and whenever you print a part, you put some money on the bank account of the machine tool manufacturer. So there are various models, but I believe at least in the couple of next years, I think selling machines as of today will be the choice. Yeah.
Thank you. Olivier, do you want to say something about it?
Yeah, so I would say that for specific market, maybe additive manufacturing is only the solution that could make the jobs indeed. For example, I have in mind some example like TIAL from GE. They develop the specific material in the machine, and there are other example for scam alloy, alloy with it's aluminum alloy with vanadium, with scandium, and they achieve very high level of mechanical properties. So for this application, you only have additive manufacturing process that can achieve this kind of level of quality. For this kind of market, maybe only the additive manufacturing can give a solution to that. So it's also a possibilities. And another, I would say, point, if you, from your design, you are able to integrate some kind of multiple functionalities. For example, if you combine structural properties with heat evacuation properties, so you will put more properties in the design, and in this case, it's better to have the machine in-house because you have a very IP on your design. And if you share that with subcontractor, you have to guarantee the IP confidentiality and so on. So I feel that it's case by case that this has to be.
So there will still be an option, to invest in an EM system, given that point of view. Oh, okay. So in the long run, then in the future, and we are going to end the panel with that question. What do you think could be, the different ways that could lead to a better integration of AM systems in industrial production chains?
From my point of view, is it okay if I start?
Yeah.
So from my point of view, it's really, we need to think about interfaces, smart interfaces, also across AM machine vendors. I know it's not, it's a pain for our customers to have different type of build cylinders, different types of interfaces across the machines, not very standardized. And I think Solo can also sing a song about it. And that's something that needs standardization. And I think that's up to the machine manufacturers to speak with each other.
Yeah.
And I honestly believe that this discussions will hopefully pick up in the next years, because the pressure is getting higher there. The other thing is really connectivity. So we are working with our software team. We're working on making our machines more connected.
Yeah.
Providing software interfaces to get data on the machine, out of the machine. I think that's key to integrate these kind of machines into the existing MES systems and the existing software packages that the customers use. So smart hardware interfaces with more standards, and then this software connectivity. That's the two levers we see as a machine manufacturer.
Michael, do you want to share something?
Yeah, I think the AM technology is now beginning to become another option in the tool shop for any technology. So I think the more reliability it gets, and you can really say, well, this is a technology as routing, as milling, as drilling, then you just need the right part for that, and then AM is going to be the choice, and that's how it will be standardized in the long run.
What about you, Olivier?
I totally agree with what we have heard just before, because indeed, when we try to connect the machine with each other, we have some difficulties from, for example, the ontology of each variable. For example, if you speak about oxygen level, this oxygen level has to be the same name for an EOS machine, an SLM machine, an IBM machine, and so on. And if we are not able to make standardization about this meaning, we will compare apple and pears indeed. So we need standardization for all the data that we get from the machine. And after, we need to be able to do something with this data, because if we store the data and we do nothing with that, we have also to implement some algorithm that can extract some KPIs from these values. And all this stuff need to be implemented in order to improve the integration of AM technologies in the current workshops. And also, because in Belgium, we work in close collaboration also with small SMEs, we also need to guarantee compatibility of this machine with already existing workshops. We cannot ask to small companies to change all the workshop in order to make integration AM, additive manufacturing indeed. So it's a lot of points that we have to take into account in order to improve this, I would say, AM integration, AM transformation, I would say like that.
Thank you. Thank you very much, Intamar. Do you have anything else that you would like to share regarding this topic? No? Thank you. Thank you very much for joining us for this panel. And we'll now have a 30-minute networking sessions before the next panel, the last panel of today begins. Thank you for joining us, and see you in the networking room for those who have any real questions for you. I can see that there's one last question that is just coming up. Is there an in-suit monitoring for knowing the density of the parted part? That's a very technical questions. I don't know if one of you will.
We do offer something, yes. So there is something. A key is then to analyze the data that comes from this in situ monitoring. That's the key, and for this there's still a big knowledge needed. But yeah, Olivier, probably you can tell more about it.
Yeah, indeed, we are still also working on these topics, indeed, and the use of AI algorithm in order to treat this data is seems to be useful. And indeed, for our point of view, we start to get good correlation between what we get from the monitoring system with the quality of the part. But it's difficult to link directly to density. It's more defect detection, and after we link to we notify which part, which zone has defect, and it allows us to use additional non-destructive testing in order to investigate, to know where we have to investigate. And it's a good next step, I would say, because if we know where we have to look in the part in order to know if we have a problem or not, we gain a lot of money because we don't have to analyze all the parts.
Okay, thank you. Thank you, Olivier. So see you then in the networking room. Thanks.
You're there. Thank you.
Yeah.
Thank you very much. Pleasure.
Yeah.